And welcome to my talk about getting started with Kubernetes operators in Java. This talk is going to be a quick intro into Kubernetes operators and how they work, and of course how you get started writing your own. My interest in operators was sparked a while back when working on a project where we were implementing monitoring. We were adding Prometheus to different clusters, and we had some configuration issues, and we also ran into some issues integrating it with Istio. So every time we asked somebody, how did you solve this? How did you work with this? Most of the time, people just came across with, well, we used the Prometheus operator, so we didn't have that issue. This is the first time for me that operators were actually okay, this is maybe something to look at, this is something to learn. And of course, once you start reading about operators, you also see the anti-operator posts, which are about, well, not always. Maybe an operator is not a good idea. You don't have to automate everything. Sometimes it's overhead. Sometimes you don't need it. And a lot of the times, operators are already out there for things that you need. So before you get started writing your own, this might be a good thing to look into. See if it's already out there. See if it's actually necessary for your use case. We'll go a little bit into the different cases where an operator makes sense, but let's start from the beginning. What exactly is a Kubernetes operator? There's different explanations and descriptions out there, starting from Operator Hub and different ones in the Kubernetes documentation and also on the CoreOS website. If we boil it down to the basics, you're really just writing custom controllers for custom resources to extend the Kubernetes API with your custom knowledge. Now, if that sounds like a lot of buzzwords that you might or might not have heard before, this is the right talk for you. We'll go a lot into the different concepts and see what actually is happening behind the scenes with Kubernetes, because most people who use Kubernetes don't actually need to know that there's an API server, that it does something, what's going on. But let's take a closer look. This is the simplified workflow that happens when you run a kubectl command. Well, in this case, actually a kubectl command that creates a deployment. The kubectl talks to the API server, and in our case, we're actually leaving out the etcd as the data plane, the data store in the back, and just pretend like it's just the API server and it knows about the different resources. So we create a deployment resource in the API server that sends an event out, and then there are controller managers, as you can see at the bottom, which are a collection of different controllers, and those are listening to the events going out. So if the deployment controller gets a deployment event, a create event, it knows it has to do something. So at that point, the deployment controller creates a replica set resource inside the API server. Once that happens, the API server sends out another event. The replica set resource has been created. So now the replica set controller gets that event and creates a pod resource inside the API server. At that point, no actual containers have been created anywhere. It's literally just resources inside the API server or inside etcd. With the pods being there, they're still not scheduled. They're not assigned to a specific node. So this is what the scheduler does. It sees there's a pod that's not been assigned to a node, and then that pod gets assigned by the scheduler. The scheduler just uses its node assignment algorithm to figure out which node it goes to, writes that node into the pod's specification, and then that event caused by the update of the pod sends an information to the kubelet that is running on the node, and now the kubelet actually creates the containers on the node. So this is a long way to see what actually happens if you create a simple deployment on Kubernetes. The two controllers, the deployment and the replica set controller we have here at the bottom, they work in a fairly simple way. They use control loops. They compare the status that we want, which is the desired state, and the current state, which is the state that they have. And if the state doesn't match the state that we want, we adapt it. So what they really do is compare the spec, so the specification of a resource. You can see that in a YAML file, you have the spec and the status. The spec is the declared or desired state, and the status is the status that it's actually currently having. So the controller compares those two and then adjusts the current state to match the actual state that we want. This can be triggered by events like we talked about in the previous slide, but it can also be regular intervals where we poll the API server to see if something has changed. So this is an example of what happens when you delete a pod and it comes back up if you have a deployment or a replica set that contains or owns the pod. So when we talked about extending the Kubernetes API with those resources, we have seen there are built-in controllers, but they are fairly limited because they are built in, so they are only for the built-in Kubernetes resource kinds. So you can have a deployment controller, replica set controller, and so on, also for jobs and garbage collection. And those are great. They do their job really well, but they don't help you if you want something application specific. If you want something for your application that is not dealt with enough by a simple deployment or stateful set. So what you can do is you write a custom resource, and a custom resource needs to be defined up front. This is something the Kubernetes API lets you do by allowing you to define your own Kubernetes resources. That lets you keep your application-specific knowledge while also having the Kubernetes features still. So for example, you get Kubernetes validation with it and defaults and versioning, and you get both of those together without having to give up either. On the left side, you can see what a custom resource definition looks like. They're basically blueprints for the then implemented custom resources. So you have the resource on the right and the definition on the left. And if you, for example, want to create a Tomcat resource, this is the example that we have here, you need the CRD. So let's walk through the CRD and see what the different parts actually are. First, we define a group and a list of names, and those are then used in the custom resource and for the Kubernetes CLI. The second part is the schema. The format and other properties, they can be specified using the OpenAPI specification. That allows you to have a little bit more validation of custom resources. So for example, you can see on the left you have the type as string for the var file, and on the right you see it has to be a string. Otherwise, the Kubernetes API would not let you post a change to that. And in our case, we're only giving the CRD 3 different properties, the var, the version, and the replicas. Then the third part is that CRDs, like most other custom resources, allow for, most other Kubernetes resources allow for different versions. And in our case, it's only one version, and we can see we're using that same version of the API on the right. It's also namespaced. In this example, you can also have a cluster-wide custom resource definition. I think the difference is obvious. One is contained to a namespace, and the other one is cluster-wide. And since we're not specifying a namespace in the custom resource example on the right, that one gets deployed to the default namespace automatically. That's it for custom resources. And now if you look at the custom controllers, you can have multiple controllers inside an operator. So if you're writing an operator, you have different options. Some people go for the Go version, which is the operator SDK, which is the most mature one and also most commonly used as far as I know. Because Kubernetes also was written in Go, so this was the straightforward way to go. Then there's the Kubernetes Universal Declarative Operator, also known as CUDO. Uses mainly YAML files to define how to write an operator. And then there's a Java Operator SDK, which is the one we're looking at a little bit more. And for anybody who would like to go from scratch, there are various API client libraries and community client libraries from Go, Java, Python, JavaScript, .NET, Haskell, Clojure, Lisp, Node, Perl, PHP, Ruby, Rust, Scala, and I'm sure in the time that I've named those, they've written at least 2 more. So those are available for anybody who wants to write a Kubernetes operator from scratch without using an SDK as a help. Some people might be asking, why would you use Java? I'm guessing in this crowd it's more likely why not, but I'm still going to go for it. So the Java community is huge, especially compared to Go. Go is growing, but for now, if you look at GitHub, the amount of active repositories for Java is like 7 million versus Go being a 600,000. And Java is moving more into a cloud native space with, for example, GraalVM or the Quarkus framework. So It's becoming more lightweight and more easy to use, especially in smaller container environments. Now, if we get started with the operator SDK, the Java operator SDK, we need a few things up front. First, we need kubectl configured. So you want a cluster reachable. Doesn't matter if it's local or remote. So I'm using the Docker for desktop, for example. You can also have a remote cluster. If you just run it in your IDE, the operator automatically picks up on the kubectl configuration and then talks to your cluster for you. Second part is the CRD and the CR for your application. So for example, like the two that we looked at for the Tomcat. Then you add a Maven dependency to your Java project to bind in the Java operator SDK. Then you can look at the examples if you want to see if there's any operator examples that make it easier for you to get started. I would recommend that because starting from scratch can be a bit of a challenge versus having an example that you just have to adapt is usually easier. Then this second to last part is actually writing your controller. So you have two important parts in writing a controller. Let's look at the code. This is an example for a controller class. An important part in the beginning is to actually annotate it to make it a controller. That it's actually looking for the CRD that it's going to be using. The second part is the create or update resource method. This one is what you want your controller to do whenever a create or upload resource event comes in from your custom resource. So let's say you create your Tomcat custom resource. What do you want to happen? Usually I'd say you want a few pods to be created, you want a service so you can actually use it, maybe some other things like a config map or something attached to it. So this is where you put that. It doesn't have to be pure Kubernetes. It doesn't have to be, I only can do Kubernetes resources. It could be anything from AWS instances to writing data to a database or even writing tables or creating tables in a database. Can be making a backup and saving something somewhere. So this is basically up to you. So whatever you want to happen when your custom resource gets created, this is where it goes. And the same thing for the delete resource method. Once you write that, you basically clean up whatever you created. So in the Tomcat example, you would delete your deployment, you would delete your service, you would delete a config map, maybe write to a log somewhere, maybe send a message that something has been deleted. Once you've done that, you can package your operator into a Kubernetes deployment. You can do that with various different Maven plugins, for example, or even manually just adding the jar file to a Docker file and then turning it into a container. So this is completely up to you. I personally like the very easy version with Maven, but let's take a closer look at the actual demo of how this is done. Let's start with taking a look at the operator. This is the operator class. It starts off fairly simple. You're just registering the client, you're creating the operator itself, and you're registering the Tomcat controller and the web app controller. We split up the Tomcat CRD into two pieces in this case. So we have the Tomcat, which only specifies the version and the amount of replicas, and the web app, which actually has the URL of the var file that we want to deploy on our Tomcat. So the Tomcat example is not perfect, and in real life I would not recommend having a Tomcat as a deployment and then deploying your var file on top of it. This is just to simulate a Java application that you could be using in place of the Tomcat, just to get this out there. We take a look at the web app controller, the create or update method, and the delete resource method. So those are basically just getting the var file and putting it there, and the same for the delete, removes the var file. The Tomcat controller itself also has those methods, and in this case we're creating and updating a deployment and creating and updating a service. So this is all this example is doing, is creating a few more resources in Kubernetes. Here we have the example of how you can automatically build your Docker image from that file or from the code you have in your operator. So let's take a look at that. If we just run Maven git docker build, we can start and build our own Docker image for the operator. This is going to take a little bit, and meanwhile I will explain why here the kubectl command that we're running does not, or throws an error. That's because our CRDs are not on the cluster yet. And we actually finished the build. That's great. Let's see if it's there. It is there. I think there's a bug somewhere in the build because I'm fairly certain this image is not 51 years old. But just to make sure, we are actually using this Tomcat operator image in the deployment file later on. Let's take a look at the cluster first. This is my Kubernetes cluster. This is the local one that's running. You can take a look. There's no custom resource definitions as of this moment, and there is only the pods running in kubesystem, which we can completely ignore. So this cluster is perfectly empty at the moment. So what we do now is we add our CRDs. And the CRDs are similar to the ones we've seen in the slides. Let's check them out. So one is the web app, which is choosing which Tomcats to deploy to, which URL we're using to get the file, and which context path we're using. And then the Tomcat CRD is the one that only has the amount of replicas and the version of the Tomcat in here. Now we check. CRDs have been applied just fine. So now we see what happens if we apply our Tomcat sample. Seem to have lost something. Oh yeah, there's a... That seems to already have been there. Delete that first to just make sure. Okay, that's been deleted, and reapply. Okay, so now we created our Tomcat sample, and now you can see the error message. Sorry, the error message went away earlier when we created the CRD, and now we actually have a Tomcat resource. If we take a look at the resource itself, we can see we have the spec down here, and we have 2 replicas and Tomcat version 9. That's fine and everything. But that's fine and everything, but we do actually want to see if we created anything. In this case, we haven't. And we haven't created anything because we don't actually have an operator running at the moment. So what we do is we delete our Tomcat sample again, and then we just create our operator deployment inside the cluster. We're creating a namespace, we're creating a deployment that actually contains the operator, and then we're creating a service account and a cluster role binding because the operator does need a little bit more in permissions to be able to create other resources inside the cluster. So we can see our pod with the operator has been created. Let's take a look at the logs. Seems to be okay. And now if we reapply the Tomcat sample, whoops, not delete, kubectl apply, we can see this time the operator actually does something. And in our case, it creates a deployment which has 2 replicas, and it also creates a service, which is a node port pointing to port 30,000, so we should have a Tomcat exposed on this port. And we do. We get a 404 because there's no web app yet. So because we have done this, we can now apply the other one, the other custom resource, which is our web app. And if we take a look at our web app, that one's also fairly simple from a spec. It has the sample as a context path. It has the Tomcat, as the Tomcat we created earlier. And it has a URL for a sample var file that we want to deploy there. So let's check out if that actually worked. If we take a look at, yes, So I'm at localhost 30,000/sample right now. And we can also take a look here again. Yeah. All right. Now that we have done that, we want to change something. Let's say we don't actually want that file. Let's say we want maybe a different var file. Let's take that one, and we write this, and this should then pull the other var file and onto our container. Let's refresh. Yes, and we have a different var file running on our Tomcat. This of course works with multiple ones because we have the context path, so you could just change that one and then go for a different. But I guess this is a good example to show why it's a good thing I'm a cloud native person and not a not a web developer. So let's get back to the demo. Now, if we do the same thing, we delete the, actually let's delete the babab here, delete the custom resource. And once we have deleted the custom resource, this should also go away. Yes, and we can see this is an Apache 9. We could, for example, also update the version. Something else that might be interesting would be taking a look what happens if we don't follow the OpenAPI specification that we said earlier. Let's say we put a string in here and it doesn't work. You get an error because it wants an integer. All right, so we've shown how to do this, and now what we do is we delete our Tomcat again. And Tomcat is gone, and the pods are terminating as well. So this is what our operator did for us in the meantime. Back to the slides. Here you can see again what we added to the previous workflow. So the workflow only changed by the orange parts. What we added is the custom resource definition, the custom resources themselves, and the operator. And what the operator does is not that much more than the other controllers do, except adding a step up front. Of course, this is not limited to Kubernetes resources. As I said, you could use AWS resources or create something somewhere. I've seen Jenkins pipelines being created, so this is basically up to you. Whatever you want to do up front or in between, this is what you can do. There's also the option of watching other resources, and for example, if pods get created, something else could be happening somewhere, but that's going fairly deep into specifics of what you can do with the SDKs. What you've seen was pretty much a basic install, so I can imagine some people asking, how is this any different from Helm? Why are you actually using an operator for that and not just using a Helm chart to deploy a servers and deployment for a Tomcat? That's a good question. There's not much different at this state, but this is not what an operator is intended to do. So an operator is not meant as a fancy install tool. An operator is meant to manage the state. An operator is meant to help you manage stateful applications that you don't have to worry about actually taking care of backups and so on. So the basic install features are just the first step. The second one is anything that goes from minor upgrades and patching to then the full life cycle, but the full life cycle also includes anything that is backups and data management that a lot of applications do have, and a lot of Kubernetes resources don't support like that out of the box. So this is basically helping you manage your application either for you or for other people. Then there's insights you can gather using an operator from metrics and different monitoring tools to just understanding how it's used and which small fixes could be done. And then there's the autopilot, which one of the operator books describes as a tiny software SRE, which I personally love, to have a SRE sitting in your cluster, taking care of your application for you. So you have the application knowledge plus the Kubernetes automation in there, and you don't have to worry that much about something breaking or like small things breaking or upgrades and everything. It's just done by upgrading or changing the custom resources, and you don't actually have to worry about what's happening in the backend. These 5 stages are how the operator framework, the Go one, defines their versions. So basically how they define the maturity of one of their operators, but I find it as a very good tool to explain the different levels of what an operator can do for you and where it is actually helpful. The book that I mentioned, I'll link to it, is the Kubernetes Operators book. There's also the documentation on operators from Kubernetes, which is very helpful, and the CoreOS blog introducing operators. There's a lot of existing operators mentioned, for example, on this GitHub link for awesome operators. There's a few more out there, but the operator hub is, I think, the biggest one where you want to check first to see if anything that you want to install, anything that you want to operate actually already has an operator. If it's not there, then that's where the frameworks and SDKs come in. So the Java Operator SDK, the Kudo framework, and the Operator framework. And this is pretty much it for my talk. Thank you very much for taking the time, and I think we're moving on to the Q&A now.